This is lesson 2.1, using a general strategy to solve linear equations. Our learning objectives are to solve linear equations using a general strategy, classify linear equations, and solve equations with fraction or decimal coefficients. Up to this point in our lessons together, we've been simplifying expressions. Today, for the first time together, we will solve equations, specifically linear equations, which you will do often in future lessons of this course. So, first of all, let's talk about the solution of an equation. A solution of any equation is a value of a variable that makes a true statement when substituted into the equation. Let's see this in practice. Example 2.1 says, determine whether the values are solutions to the equation of 5y plus 3 equals 10y minus 4. First, they give us a value y equals 3/5. So we have to take this equation and rewrite it with y being replaced. So here I'm inputting 3/5 for y. So our question is, are these two sides of the equal sign, are these two expressions equal to each other? So 5 times 3/5 is just 3. 5 cancels 5 there, and you get 3 plus 3. And we're asking, is that equal to, well, 10/5, 10 divided by 5 here. See, that cleans up to 2. And 2 times 3 is 6. And then I subtract 4. And 3 plus 3 is 6. And 6 minus 4 is 2. And so my resulting statement says 6 equals 2, which is not true. 6 does not equal 2. Therefore, 3/5 is not a solution to this equation. Let's try it again, substituting 7/5 for y. 5 times 7/5 plus 3 equals 10 times 7/5 minus 4. Is this a true statement? Well, once again, 5 divided by 5 is 1. 1 times 7 is 7. I add 3. All right. 10 times 7/5. Same idea here. 10 and 5 become 2. 10 divided by 5 is 2. And 2 times 7 is 14. And I subtract 4. 7 plus 3 is 10. 14 minus 4 is 10. Wow. This resulting statement is that 10 equals 10. That's a true statement. So the value 7/5 when plugged in for the variable made the statement true. Therefore, it is a solution to the equation. Great. Like always, when I finish any example, you can pause this video and do the try it part on the right-hand side. So let's talk about linear equations specifically. A linear equation is an equation in one variable that can be written where a and b are real numbers and a cannot equal 0, as a times x plus b equals 0. Now, I'm going to be very straightforward with you in what a linear equation is. It's when the highest power of the variable, let's say the variable is x, its highest power is 1. Okay, so x to the first, when you see this in an equation and it's the highest power of x, there's not an x squared or an x cubed or anything else, this is called a linear equation. If we were to graph it, it would form a line. That's why we call it a linear equation. Now, that first power is invisible, right? So when we have something raised to the first power, it's invisible. The 1 is invisible. All right, so let's go ahead and learn how to solve linear equations. Okay, our goal is to get the variable all by itself on one side of the equal sign and everything else to the other side of the equal sign. All right, so when I see 7 times n minus 3 minus 8 equals negative 15 in this example 2.2, well, I have to have a strategy for getting the variable n all by itself. And to do this, we're kind of thinking when we solve algebraic equations to do the opposite of PEMDAS. So instead of doing parentheses stuff first, we would want to start on the other end and do the addition and subtraction easy stuff first, then the multiplication and division stuff, and then any exponents, and then parentheses. Let me show you. You'll get comfortable with this as we go. So as I look at this equation and I want to get n alone, first I say I need to add 8 from left to right. So I get 7 times n minus 3 is equal to negative 15 plus 8, which is negative 7. Next I say, well, I need to divide 7 from left to right. And so now I just have the n minus 3 stuff that was in parentheses, and it's equal to negative 7 divided by 7, which is negative 1. And then I say, well, now I need to add 3 from left to right. And so I get n equals, well, negative 1 plus 3, which is 2. I have solved the linear equation. This is the strategy. This is the approach to get it done. Now, every linear equation that you see, well, you're going to have to look at it and decide how to get the variable alone, how to isolate it. Let's try this again in example 2.3. So here I see 2/3 times 3m minus 6 equals 5 minus m. You'll notice how this equation is more developed than the previous, because now we have the variable m on the left-hand side of the equal sign and the right-hand side of the equal sign. All right, so go ahead and watch how we go through the solution process for this. Now, one of the first things that I would do is distribute. So I'm going to distribute 2/3 into both the terms inside of the parentheses. So 2/3 times m, well, this 3 kills this 3. They cancel each other. So 2 is multiplied with m. So I get 2m. And then 2 times negative 6 is negative 12. And that equals 5 minus m. Next, my goal is to get all of the terms that have m in them to one side of the equal sign and all of the constant terms to the other side of the equal sign. So all the terms with a variable go to one side, all the constants without a variable go to the other side. So what I would do in this case is I would add m from right to left and add 12 from left to right. Now, let's see what cancels. What stuff cancels here? So this stuff will cancel out. This stuff will cancel out. And when I rewrite everything, 2m plus 1m is 3m, and that equals 5 plus 12, which is 17. Next, well, I've got to get m alone, so I have to get rid of the multiplication of 3 by dividing 3 from left to right. And so now I have solved for m. The variable m is equal to 17/3. Great. Since every equation that we look at is a different equation and we have to look at it and analyze and figure out how things get moved around, we need to practice this a lot. So I'm going to keep doing some more examples and they will increase in complexity so you can practice with me. Example 2.4. Solve 4 times x minus 1 minus 2 equals 5 times 2x plus 3 plus 6. All right, so we see variables on both sides of the equal sign again, right? The variable x is on both sides of the equal sign. Its highest power is 1, therefore it's a linear equation. All right, let's go. So I would distribute into the parentheses first in both sides of the equation. So I get 4 times x and 4 times negative 1 minus 2 equals 5 times 2x plus 5 times 3 plus 6. So I've started to rewrite everything. At this point, I might ask myself, are there like terms on either side of the equation that can be combined, making things simpler? And the answer is yes. I have constants on both sides of the equation that could be simplified at this point. So let's go ahead and rewrite this as 4x. Well, negative 4 minus 2 is negative 6. And then 10x plus 15 plus 6 is 21. At this point, we can move all the terms with the variable to one side and all of the terms that are constants to the other side. Let's do it. So I would subtract 4x from left to right and subtract 21 from right to left. But you could do it the other way. It doesn't matter which way you decide to do it. All right? The reason I did it the way I did it is because it keeps the coefficient with the variable positive instead of negative, so I don't have to divide by a negative number at the end. Now, let's see what cancels. Great, so those things cancel, I don't have to pay attention to them. Negative 6 minus 21 is negative 27, and 10x minus 4x is 6x. And now I divide by 6, right? Because my goal is to get the variable alone. Division by 6. Let's do that in red for fun. And so I find out x equals negative 27.6, which you can reduce that. You can reduce negative 27.6 to a smaller fraction because both values are divisible by 3. And so I end up with negative 9 over 2. Well, let's move forward into our next example, 2.5. We want to solve 10 times 3 minus 8 times 2s minus 5 equals 15 times 40 minus 5s. You'll recall that grouping symbols are parentheses, and if we've already used parentheses, then the larger would be using brackets. But they're just grouping symbols, but they're kind of embedded into each other. So my strategy would be to distribute into the binomials we see, right? The parentheses have two terms. We call them binomials. Well, let's go ahead and start to clean this up little by little. I have 10 times 3 minus, well, 16s, and then plus 40. Let's describe that a little better. 8 times 2s, well, it's not just 8, it's negative 8, you see, because that negative symbol is right there. So negative 8 times 2s is negative 16s, and negative 8 times negative 5 is positive 40. Always pay attention to the sign in front of the coefficient you're distributing. All right, so let's move on, and we find out that equals 15 times 40, which, well, 15 times 40 is 600 minus 15 times 5s. Well, 15 times 5, well, that's 75. So I get a 75s. We notice that some of these coefficients have larger values, like 600 and 75. Let's continue to clean up and see what happens. Okay, so I notice in the brackets I have two constants that could be combined together. Let's go ahead and do that. I have 10 times, and I don't have parentheses anymore, so I could turn these brackets into parentheses. Negative 16s, and 3 plus 40 is 43, so I have a plus 43 here. And now I can distribute this 10 into these terms, and I get negative 160s plus 430 equals 600 minus 75s. Now, just because these are larger numbers doesn't mean we can't do the same thing we've been doing. We see the variable s on both sides of the equation, so we want to move all the terms with variables to one side and all the constant terms to the other side. If I were you, I would maybe add 160s from left to right, and then subtract 600 from right to left. This will do the trick. Let's see what things cancel. So that disappears, that disappears. And 430 minus 600, this might be a time where you finally get out the calculator for the first time in the course. So, you might do this in a calculator really fast, and you'd get negative 170. And that's equal to negative 75s plus 160s. And so we get 85s. And the last thing to do would be to divide by 85. I'm going to do it from right to left. And so I find that S is equal to negative 170 divided by 85, which is negative 2. There we go. So you'll notice we have just worked on our strategies for solving linear equations on 4 different example problems. Great. Well, let's move forward. And now it's time to talk about classifying equations. So there are different types of an equation. And those 3 different types are conditional equations, identities, and contradictions. So a conditional equation is one that is true for one or more variable values and false for all other values. Now, it has one or more solutions. So it could have one solution or it could have more solutions, but it doesn't have infinite solutions. Now, an identity is an equation that is true for any value of the variable. So you could plug anything in for the variable as a number, and anything works. It makes the equation true. So the solution would be all real numbers. And then there are equations that are contradictions. Contradictions are false for all values of the variable. So whatever you plug into the variable, the equation is not true. It doesn't work. So there is no solution to an equation that is a contradiction. Now, you don't know what type of an equation you're dealing with often at first. So in these examples, 2.6 through 2.8, we're going to learn how to classify the equations that we see as conditional, identities, or contradictions, and then state the solution. All right, so we start off with just an equation like we've seen before in example 2.6. And we want to solve this equation for the variable n. And you'll notice I see n here, here, and here. It's on both sides of the equal sign. So we're just going to start to see if we can get the variable n all by itself. Let's go. If I were you, I would distribute things in this case. So let's distribute, and we'll have a lot of terms, but we'll start to clean them up little by little. 6 times 2n, 12n. 6 times negative 1, negative 6, plus 3 equals 2n minus 8 plus 5 times 2n, 10n, plus 5 times 1, 5. Now, let's see if there are any terms that are like terms that we could combine together, right? So on the left-hand side of the equation, we see 12n minus 6 plus 3 becomes a negative 3, right? Negative 6 plus 3 is negative 3. And then I see a 2n and a 10n, which I could combine together to make 12n, and a negative 8 and a positive 5, which can be combined together to make a negative 3. And I get to this point, and my equation says 12n minus 3 equals 12n minus 3. Well, I want to get all the variables to one side of the equal sign and all of the constants to the other side of the equal sign. Your brain might tell you what's about to happen, because if I decide, oh, I'm going to subtract 12n from right to left, and then add 3 from left to right, there's something wild that happens. Because now we had the same coefficients with the variable and the same constant value in the equation. So these cancel, these cancel, these cancel, and these cancel. What I end up getting is an equation that says 0 equals 0. All right, so if this is the case, if you get no more variable, if the variable cancels and it disappears, remember that's what we were trying to solve for. But we get one number equals another number and it's a true statement. Yes, 0 does equal 0. Then this is an identity. Okay, so we're going to classify this as an identity. That means no matter which number you plug in for the variable, it is a solution to the equation. Okay, infinite solutions. Remember, an identity has infinite solutions. Okay, and when you try to solve an identity for the variable, it will disappear. It'll cancel out. All right, let's try example 2.7. Looks a little simpler. Great. So we have 8 plus 3 times a minus 4 equals 0. You know, the first thing I would do is distribute this 3 into both those terms in parentheses. So we have 8 plus 3a minus 12 equals 0. Now, let's see, are there any like terms we could combine? Yes, there are some constants like 8 minus 12. So I'm going to rewrite this as 3a minus 4 because 8 minus 12 is negative 4, and that equals 0. All right, now our goal is to get the variable a all alone. So if I were you, I would add 4 from left to right. And so now we have 3a equals 4. And now, if I were you, I would divide 3 from left to right. And I find out that a equals 4/3. Great, we just solved this linear equation and we found out it has one exact solution. The variable equals 4/3. Let's go back. This is a conditional equation, right? Let's identify this. This is a conditional equation because it only has one solution. It could have more than one solution, but it can't have infinite solutions. Great. Let's move on to example 2.8, and let's solve for the variable m to see what type of an equation this is. All right, so our goal is to solve for the variable m. If I were you, yep, I would distribute first, all this stuff. All right, so we have 5m plus, well, 3 times 9, 27, plus 3 times 3m, 9m, equals 2 times 7m, which is 14m, and 2 times negative 11, negative 22. Great. So you just distributed and you got to this point. Now you should ask, are there any like terms that can be combined together to reduce the amount of terms that we see? The answer is yes, like 5m plus 9m is 14m. On the right-hand side, nothing else can be combined together, so that's all we have, right? So what did I just do? I just took 5m and added it with 9m to make 14m. Great. So moving into the next part here, well, our goal is to now get all of the terms with the variable to one side of the equation and all the constants to the other side of the equation. So I'm going to subtract 14m from right to left and subtract 27 from left to right. Let's see what cancels. Great. Also, that cancels too. So on the left-hand side of the equal sign, everything canceled. All I have is 0. And negative 22 minus 27, well, that gives me a negative 49. So I've done all this work and I've found something that says 0 equals negative 49. And I noticed the variable disappeared. We were trying to solve for the variable. It all canceled. And we have something that's not a true statement. Look, 0 does not equal negative 49. So how would we classify this equation that we've just tried to solve for? Well, that's called a contradiction, right? So it's false for all values of the variable, and there is no solution. Okay, this is a contradiction, right? We know 0 does not equal negative 49. That's why it's a contradiction, and we couldn't solve for the variable. All right, so let's go ahead and move forward. Our last objective today is to solve equations that have fractions or decimal coefficients. All right, so oftentimes we'll encounter linear equations. They will have these fractions, and you'll recall last lesson we worked with fractions, making sure you were comfortable with them, and you've had that practice now in your assignment. All right, so one thing to know is when we try to solve fractions that have, when we try to solve equations that have fractions in them, well, we want to get rid of the fractions. That's a really good objective, right? Like, let's get rid of the fractions. And how can we get rid of the fractions? Well, we can multiply the entire equation by the least common multiple of the denominators. So I look at this equation, I see the denominators are, in this case, 12, 6, and 4. And the least common multiple of 12, 6, and 4 is 12. All right, so there we go. Now, if you had to figure that out, just not knowing in the first case, you would create a list of the multiples of 12, like 12, 24, 36, etc. And then you'd create a list of the multiples of 6. Well, 6, 12, 18, 24, etc., right? And then you'd create a list of the multiples of 4, 4, 8, 12, 16, right? This is what we did in our previous lesson. And something you'll notice is that 12 is the first number that appears in all three of the lists. And that is why we're saying that 12 is the least common multiple of these denominators. Oftentimes we'll just call it the least common denominator. Now, why did I do all of that? Because now, if I distribute the least common multiple into all of the terms of this whole equation, right? Every term of the whole equation, then something cool happens. We get rid of the fractions. 12 times 1, 12. Well, that's just 1x. Okay, so this 12 right here will cancel this 12, and so we end up with 1x. Okay, so that's what we'll write, 1x. Okay, now let's distribute 12 into 5, 6. Well, 12 divided by 6 is 2. So we're going to end up multiplying 2 times 5, right? Well, 2 times 5 is 10. And now 12 divided by 4 is 3. All right, so I get 3 times 3, which is 9. Well, great. We have just gotten rid of all of the fractions, right, by multiplying the entire equation by the least common multiple. Now look how simple our equation is. X plus 10 equals 9. So all I need to do to get the variable x alone is subtract 10, and I find out that x is equal to 9 minus 10, which is negative 1. All right, let's try again. So in example 2.10, my goal is to solve 5 equals 1/2 y plus 2/3 y minus 3/4 y. And once again, I'm like, well, how do I handle these fractions? And I look at the denominators, and I say, what is the least common multiple of the denominator 2, 3, and 4? If you can't think of it right off the bat, you could create a list of the multiples of each of these denominators and then make the decision. But really fast, I would think that the answer would be 12. Okay, so I'm saying 12. Let me prove it to you. So if I took the multiples of 2, let's do this in blue, 2, 4, 6, 8, 10, 12, 14, etc., right? Multiples of 2. And then the multiples of 3, 3, 6, 9, 12, 15, 18, 21, etc. And then I took the multiples of 4, 4, 8, 12, 16, 20, okay, etc. Well, which number came up first on all three of those lists? And the answer is 12. 12 is the first number which appears on all three of those lists of the multiples. That's why I'm choosing 12. Now I can distribute 12 into all of the terms of the equation, and it will get rid of all fractions. They'll be gone. Well, 12 times 5 is 60. That equals 12 times 1/2 y, which is 6y. You all agree that half of 12 is 6. Now, 12 times 2/3 y. Well, 2/3 of 12 is 8. So I get 8y. And then 12 times negative 3/4 y. Well, 3/4 of 12 is 9. So I get a negative 9y. There we go. Hey, congratulations. You just got rid of all the fractions. Good job. Well, this cleans up, right? Because 6y plus 8y minus 9y, those are all like terms with y in them. So 6 plus 8 is 14. 14 minus 9, that's 5. So there are 5 y's here. The very last thing to do is divide by 5 on both sides of the equal sign, right? So we've now solved for y. We got y all alone. Y equals 60 divided by 5, which gives us 12. Lots of 12s going on. Y equals 12. There we go. Well, let's try another. Here's example 2.11. Solve 1/2 times y minus 5 equals 1/4 times y minus 4. Well, let's go ahead. Do you want to distribute? Maybe let's just distribute and we'll figure things out from there. So 1/2 times y is 1/2 y. 1/2 times negative 5, well, that's negative 5 halves. That equals 1/4 times y, and then minus 1/4 times 4. That's just 1. Right? 1/4 of 4 is 1. There we go. Now let's look at the denominators of, well, our denominators in this case are 2 and 4. And the least common multiple of these denominators is 4. So if I distribute 4 into all of these terms here, of the entire equation, I can rewrite everything without fractions. So 4 times 1/2 of y is 2y. And then 4 times negative 5 halves is 10. Right, so I get a 2y minus 10 on this side of the equal sign. And then 4 times 1/4 y is just y. And 4 times negative 1 is negative 4. So we've gotten to this point, and we notice there's no more fractions. Awesome. So now let's get all of the terms with the variable to one side of the equal sign and all of the constant terms to the other side of the equal sign. So I'll subtract y from right to left, and I'll add 10 from left to right. Great. So 2y minus y, that's just 1y. So we get y, 1y, equals negative 4 plus 10. which is 6. We found out y equals 6. All right, let's move forward. Here's example 2.12. Our goal is to solve 4q plus 3 divided by 2 plus 6 equals 3q plus 5 divided by 4. I'm going to zoom in just a little bit here. And things might look a little scary, but just look at the denominators. Our denominators are 2 and 4. So we could multiply the entire equation, all of it, by the least common multiple of 2 and 4, which is 4. And then we can distribute that into all 3 of the terms of the equation. So let's go ahead and do that. So 4 divided by 2 is 2. So 2 would get multiplied with 4q plus 3. Then I have a plus 4 times 6, 24. And that equals, well, 4 divides 4, and that's just 1. And 1 times 3q plus 5 is just 3q plus 5. All right, so now we're to this point, and we think, well, let's distribute this 2 into these terms. So we'll get 2 times 4q plus 2 times 3 plus 24 equals 3q plus 5. And then we see we could combine, like terms there and there, right? Let's combine those. And we end up with 8q plus 30 equals 3q plus 5. Now let's get all of the terms with the variable to one side. So I'll subtract 3q from right to left. And let's get all the constants to the other side. So we'll subtract 30 from left to right. And some things cancel here, like boom, that cancels, that cancels. 8q minus 3q is 5q. And 5 minus 30 is negative 25. So I now have 5q equals negative 25. Let's divide by 5, right? And we're done. Yeah, negative 25 divided by 5 is negative 5. So q equals negative 5. This is the solution. There we go. And we're going to finish with one last example today, and that's example 2.13. What if we have, instead of fractions, what if we have decimals? How do we handle that? Well, what we could do is multiply by a certain multiple of 10, right? So if you multiply by 10, that moves the decimal over a certain amount of spaces. But you might have to, if there are 2 decimal places, you might have to multiply by 100, and that gets rid of the decimals. So there's an approach that we could take. Let's go ahead and try. So if I were you, I might multiply all of this by 100, and then distribute that into all 3 terms. Boom, boom, boom. So multiplying 100 times 0.25x becomes 25x. 100 times 0.05, well, that's 5. And 100 times 2.85 is 285. All right, we're just moving the decimal 2 places to the right in each one of those numbers. And yeah, that might make big numbers, but what's nice is you don't have any more decimals. And we can handle big numbers. So next, we want to make sure to distribute this 5 into both of these terms in parentheses. And so we end up with 25x plus 5x plus 15 equals 285. Let's combine like terms and move variables to one side, constants to the other, right? So 25x plus 5x equals 30x. And let's just immediately subtract 15 from left to right so that we can combine constants. 285 minus 15 is 270. Well, 30x equals 270. So if we divide 30 from left to right, getting tight on space here, well, the answer would be x equals, well, 270 divided by 30. That's like saying 27 divided by 3, which is 9. Great, x equals 9. Wow, so in this lesson, we, let's do a quick overview. We have learned that we could plug any number into an equation to see if it's a solution to that equation, if it makes the equation true. We've also learned strategies for solving linear equations, right? And we developed your skills making those linear equations more complicated over time. We've talked about conditional equations, identities, and contradictions, and that when we try to solve an equation, we could end up with any one of those three, right? The first one we tried to solve for was an identity. The second one we tried to solve for was a conditional equation. The third one we tried to solve for was a contradiction. Then we said, well, how could we solve linear equations with fractions? Remember, multiply everything by the least common multiple. And decimals. Oh, well, multiply everything by multiples of 10, or, powers of 10, 10, 100, 1,000, depending on how many decimal places you have. Well, I hope that this lesson has been helpful for you. You do have a homework assignment in WebWork for this, and best wishes as you make those attempts.